So welcome to my YouTube channel and to my work. Thanks for viewing my work. I'm by the names of Nampewa Margaret with the biometric attendance system. So now today I'm back with the data cleaning and the exploratory analysis, and so that's what I'm with today. And so I'll go through the heat maps, I'll go through the patterns among all the other methods. So I will start straight with the heat map. So a heat map, so a method or is a method of graphically representing values by color. So actually we represent values, or we analyze and visualize complex data by means of colors. So we follow the patterns of colors and then visualize what actually the data depicts. So that is what heat maps are. So heat maps actually also deal with numeric data. So you cannot develop a heat map when you have strings or characters. You have to be with numeric, either float or integers. That's the data type that suits better the heat map. So actually to develop a heat map, I used the Seaborn and Jupyter Notepad. So I installed Seaborn and then tried to import the library into the Jupyter Notepad, and this is what I tried to come out with. As you see, I initially explained that we use colors to depict the complex data, and that's what I tried to come out with. So I straight go through the correlation matrices, and a correlation matrix is just a simple table displaying the correlation coefficient of different variables in your data set or in your data. So just it's a tabular representation or display of the correlation coefficients of the various variables, and that's what I try to come out. Actually the images I'm trying to present here not got from somewhere or from some website or from any other source, but I try to code these and I'll try to attach my file containing my code. Yeah. So with that, I will directly go to the box plot, and the box plot is a method for graphically demonstrating the locality or the spread of the numeric data through their quartiles. So actually, in summary, the box plot summarizes 5 values, all numbers, and that is the minimum, the lower quartile, the median, the upper quartile, and the maximum value. So that is, it summarizes all the 5 figures in one diagram, if I may say. And in addition to that, a box plot can also help us to easily detect the outliers, and those are the values that are far away from these other 5 numbers I have tried to explain. So, but we will see more about the outlier plot. So, and this is the box plot I tried to come out with. Yeah, that's my box plot, and if you look at it, it contains the other 5 numbers I was trying to explain. The median, you can see the median in the middle, the lower quartile, the upper quartile, the maximum, the minimum and the maximum figure. So those are the values. That green line is the median. So you have the upper quartile, the lower quartile, then the minimum value, which is this lower, the lowest one at negative 60, and then you have the upper quartile, that is the maximum value, that is the negative 10. Yes. So I'll go to the patterns of interest. As you hear the word patterns of interest, So remember, in machine learning, we are aiming at training our machine to actually do things as a human would have done them. So we are training at those to look at the patterns that we are interested in for the machine to grasp, such that it outputs work the way human would have done it. So those are the patterns of interest, and that's what I try to come out with as my patterns of interest after performing the code in the back end, as we will see in the attached file, in the Python file. Yeah, so we are here on now outliers, and now as I hit on the outliers, when we are looking at the box plots, are just those observations that lie in an abnormal distance that are so far away from these other values. So they exceed actually the minimum and the maximum value. They are just like they are not part, you can say they are not part of the data or other figures, but actually they are part, but they are at a distance, abnormally far away from other values. So this implies that the outliers are these values that are beyond the minimum and the maximum values on the box plot. Now, like if I try to take you back to the box plot, you can see we have here our value at negative 60. That is our minimum. But if we go to negative 10, we have a value that is our maximum. But you can look at values that are beyond, because they are beyond the maximum. So those are the outliers. They are a bit distant from these other 5 figure numbers, or the 5 numbers of the box plot. So there are many other ways of determining the outliers, but I chose to use the box plot because I already developed one, so I saw it easier and more efficient, if I may say. So directly I will take you to the feature dependence plots. So this just shows a marginal effect that features have on the predicted outcome of a machine learning model. So it actually shows whether the relationship between the target and the feature is either linear or monotonic or even more complex than the latter mentioned. So I try to cite some references that have helped me to come out with my work, and I remain Nampeo Margaret. Thanks for listening. Thanks for subscribing to my work. Stay tuned. Thank you.